designs or whatever that you do, right? So you have to be able to move fast, make a lot of decisions, and move on and do on to the next thing, right? And you'll be stuck with this freaking product if you don't get the algorithms defined and hand it off to the computer programming guys to do it, right? And so this is like it's like a freedom call, right? So you guys should get out there and define these algorithms and eliminate your job, and that will differentiate you from the world population of mechanical engineers, which are coming to get you, right? Here they're coming. Here they come, right? Offshore everything, right? That's what corporate America is, right? Get it out of America. Go build it in Singapore, right? Because the people are cheaper there, right? And you know, but I manufacture stuff in America, right? I manufacture it in the Bay Area, actually, right? And so what I think it shows you is that, you know, you got to ask the right decision. You got to ask the right question. You got to ask yourself, how can we do it? What do we need to be able to do it? And looking at the Pareto, we did something very simple, structured problem solving, which was, we looked at a Pareto and said, aha, that's the problem. If we go solve that problem, that will turn it back into a classical problem, right? By which manufacturing is the bottleneck, and then we could go work on the manufacturing stuff. And people are all working on the manufacturing stuff. So in any case, right, people love custom solutions, right? I'm telling you, my customers can't live without my custom solutions. Right? There's no standard interface. They make their product. All their products are differentiable from their competitors' products. And so people love custom solutions. Custom solutions are very expensive when you use traditional methods to design and manufacture. Right? Hey guys, this is a new world, right? It's new, this crazy computers. And oh, by the way, and the thing that we did, a human didn't touch it when we designed it. A human didn't touch it when they defined their need. A human didn't touch it when we designed it. A human didn't touch it when after it got prototyped, right? It was prototyped on a machine, like information streams into the machine and then it prints, right? Maybe a human had to pick it up and, you know, knock off some edges or something and install the shades, right? And it got into a FedEx box, right? And it got routed through a bunch of machines and it showed up at your door. And the guy had to bring it up and put it on your door. But in the future, I bet he doesn't. Maybe that's not a guy, right? Maybe that's a little bit longer, right? But this is kind of neat. That's kind of a neat way to, that's a neat world that we're all going to live into. So you are all now enabled, so there's no excuses for anybody who is here today. You're all enabled to go do this. Run forward and please do this. And just be kind to humans, right? It's like, it's all these mechanical engineers that were, the field of mechanical engineers that were sitting in my company. Right? All this resource, all of this money, all this investment into these people to do things that weren't algorithmically defined. Right? And you know who my best customers for algorithmic approaches like this are? The mechanical engineering department. Right? And they're spread, and we spread this throughout the company. We're not, you know, our designs, we do a lot of automation. So in any case, you gotta think this way. Well, it's one way to think. I'm sure you guys can play variation on the thing. You're all very, very smart people. Right? So you got a gift today. I gave it to you, right? You can use it, and you can be nice to your friends, and then we'll make other really cool products together. So we'll free up a bunch of resources. All right. So that's it. That's it. Do you guys have any questions I can answer? Somebody's got to have a question, right?
So do you envision just having this black box where you say, I want this thing, and you just plug in the numbers and it shows up?
Yeah, well, I think that like whole like talking to a box and it shows up and you have it right away. I don't know that that's going to happen, right? Because there's a lot of manufacturing know-how and knowledge and like things that people do. I think probably a first step to that kind of Jetsons kind of right? It was kind of Jetson-esque, right? I want this, and boom, it would come down and show up, which is kind of cool, right? I think the first aspect is kind of what I just described to you. Is the first step to get to that place is, you know, we have this interface, technology interface that we work with, right? It goes out somewhere in the world, gets made, gets back to us, and we can use it, right? Because having all the manufacturing know-how in one little spot, I think that's going to be a harder problem to solve than have it happen. But I agree that transportation, you know, one of the things that that's really important about learning how to get down to like what's called lean manufacturing is removing waste, right? And waste is any motion that doesn't go into adding value to the product for you, right? And so that motion of the information travel is very fast, right? That travels there, and then things are made, and then that product has to ship all the way back to you, right? There's no value add in that shipping motion, right? So this would be a way to eliminate waste. Yes, in the back.
How would you feature reliability into this vision for design?
Reliability. So reliability is baked in. So we bake our reliability into the limits that we put on those on the design, right? Like the thickness of the glass of the edges of the glass, it can't be less than 1.5 millimeters. Why? Right? Why is that? Well, below 1.5 millimeters, I suspect things are going to break too easy, right? My kids are going to grab and throw my glasses down, they're going to shatter, right? It's no good. So if I keep it above 1.5 millimeters, I feel like that's reliability. But it's a very important question that you ask, and there's an extension of that question, which is, okay, great, you got this reliability response, right? How do we fix it? But imagine that now, instead of you managing humans who are making those decisions for you, right? You're now managing a computer with rule sets, right? And you're like, oh, we noticed that on these designs where the thickness comes out at 1.5 millimeters, we're having early failures and warranty. We're spending money replacing things due to warranty issues, right? We need to go back and revisit, right, the studies that we did there, right? So you can manage these rule sets to help in the future make your products much better. And it's really cool when you do this because you get this learning through the design phase that you would never, it's just so hard with humans to manage that, right? You have training, you have formal documents, right? But when Bobby forgets about a rule, right, and there's 100 rules, right, or hundreds of rules, right, and he had a bad day because whatever, this kid has a toothache, and he had to take him to the dentist, and he was rushing to the, there's just reliability. I just can't get reliability out of people all the time either, right? So, anyways, yeah.
What about managing subjective things like aesthetics, for example, for product design? So for the glasses here, you have your dimensions that are, let's say, optimal with respect to memory, with respect to weight, that sort of stuff. But then, if the thickness of your arm is really not proportional to the shape of the glasses, then it's an ugly product, right? No one wants to.
Exactly. So the very cool thing about this situation is I had a really interesting experience maybe 4 weeks ago, right? Where I wanted to get these stickers made, right? Stickers are fun, and you can throw whatever you want on them, and you can make them for very cheap, right? So I was having these stickers made, and so I went to this website, and it says upload your imagery. And absolutely, I would love to. I upload my image, right? And it says, and it does some crunching, and it's like preview what your sticker is going to look like, and it shows me exactly what the sticker is going to look like, and I can accept it, right?
Yeah.
So I think you could have the same thing here. That's one way, is that actually you don't decide what is aesthetically pleasing for that person, right? It's that person can decide, but there's another way. In genetic algorithms, not genetic algorithms, but in multi-objective function analysis, one of the things you can do is you can calculate these things called Pareto points. And you can calculate all this Pareto frontier, right? And you can actually, you can learn a lot about what the solution space looks like. And using genetic algorithms, there are different rules that you can program in for aesthetics with respect to how things should be in proportion to one another. And the other thing you could do is you have a 3D model of that person's head, right? I suppose you could teach a computer to look at it and say, is it aesthetic? Does it look nice, right? Because what is the symmetry? What is in ours it was all symmetric, but how does it look on their head? And I suppose if you showed them the computer a bunch of things that looked good, then it can make relative comparisons and inferences for you. And I think that like how big are the lenses relative to the face, right? And even on Oakley, there's this very strange thing that I saw was the Asian fit sunglasses. They have a category which is just just, it's called Asian face. Like there must be something about the face which is different, but they had it just for that category, and I was like, wow. Here they're acknowledging that there's some special thing that a certain category of customers wants. The fit doesn't fit them on these other ones, so we're going to give them something that fits them better, right? But if it was custom and we had these aesthetics in the program, it would be able to make that decision for them, it was really interesting. You should go to Oakley.com, check it out. I'm not kidding. All right, questions? More questions? Yes.
How has adopting the system changed how you talk to your customers?
Dramatically. Well, you know, the thing is that I can have designs show up immediately, right? And so more than that, it's just that, you know, we can react to things that computers produce faster. Now we start managing exceptions rather than managing everything, right? So when I'm only having to manage exceptions, that opens up my throughput pipeline, which allows me to provide more designs to my customer, and that's the impact. That's the impact case.
And how do they feel about like automated design? Can you get that to them?
No, people who work in this area, we have to connect every tester every single time so they have a test interface and they have a wafer. So they have to connect this channel to some point on the wafer, right? So every single time they make a wafer, we have to connect that point from here to here, right? And you have to control all these different variables. So their designs are all automated too, by the way. So I think they're probably happier with computers doing it. Because there's a quality and reliability issue, right, that they can get away from when we do automated design. Other questions? All right, 15 minutes early, right?
Okay, one more question.
Yeah.
So, is there a global solution? Is there such a thing?
A global solution for... Oh.
For a pair of glasses for dochobbs, what is the...
Man.
Do you think there are too many constraints or...
No, I mean, I suppose somebody can go do. Somebody could probably try to figure that out. I mean, any problem solvable with time, money, and resources, right? And I suppose we could try to figure that out. But the rate at which technology changes, right? How I kind of see things working is that, you know, we build technologies, right, that they get used, and then we build new technologies that replace them, and new technologies that replace them, and new technologies that replace them. So I suppose if you came up with a global solution to the best set of sunglasses for Eric, and it wasn't a scalable solution, then it would go away and it would suck, right? But I kind of feel like this iterative way of producing things, getting feedback from how customers like to use them, making a next generation product to meet their need, I think it allows us to respond faster. But maybe in the future you could do that. I don't know. I don't know. I don't know how to do it yet, but I have a recipe on how to do this one. Right? So, an algorithm, by the way, there's an algorithm on how to do this, right? Now, there's one heuristic kind of step in there, which is you have to define the model and the parameters, right? So, if you can automate that, then, you know, when a customer comes to you and says, I want a faster horse, you can show them a car that doesn't exist, right? It didn't exist. So this is kind of like genetic algorithm kind of stuff, right? It makes things that don't exist. Right, it tries to make these crazy. So I'm sure it's possible. Yes.
So what do you think the trends are for the industry, the mechanical industry, and the engineering industry as well?